Yes, good afternoon all my dear students. Welcome to the another chemistry class for the thermodynamics. Hope all of you are fine, doing well and great, and I hope all of you are ready for the today's class. So as we were discussing yesterday, today we will be discussing one of the important and high weightage chapter, that is thermodynamics. So those who are joined here, please let me know whether you are ready for everything so that I can start the class now. Students, please give me some thumbs up or some reactions so that I can start the class. Yes. Okay, thank you for your response. Yes. So just tell me whether I am audible and visible properly to you or not. Just tell me my audio, whether my audio is very clear or not. Okay. So I think everything is fine and working well. So students, today we will be starting the important chapter, that is thermodynamics. Last class we have started the chemical bonding chapter, and that was little bit lengthier and bigger chapter. Some questions are there which was unsolved. I have shared all these things in the group. I hope you have done the solving of those questions and all. And if you have any doubt in that questions, you can reach out to me in WhatsApp, and also you can ask right now in the class also. There is no problem, I can clear it. Okay. Yes. So we'll be starting the thermodynamics chapter. So as we have discussed in the beginning of the class, this is a little bit high weightage chapter, that is 2 to 3 questions you can expect, and it's a very big chapter. I am not sure that I can able to complete this chapter by today. I will be taking this chapter today and tomorrow. Yeah, there is two parts there, thermodynamics and thermochemistry. Thermodynamics probably I will be finishing it by today, and thermochemistry part I will be taking few half an hour or 1 hour tomorrow, and we will be finishing up the chapter by today and tomorrow. Okay, because this is a little bit difficult chapter. Conceptual understanding is more important for this chapter, particularly for a NEET student. So yeah, so without wasting the time, we can start the class. So students, today we will be discussing the important topics: extensive intensity properties, first law of thermodynamics, isothermal process, adiabatic process, isochoric, enthalpy changes, entropy, Gibbs free energy, heat capacity. These are the important topics that we will be discussing today. Okay, so first of all, before going to this chapter, let me give you a quick idea about this chapter. This chapter is all about system, surrounding and boundary. System, it's a small part which is under our observation. That is what system. Anything apart from the system, we will be considering it as surrounding. And the system and surrounding is separated by a boundary. It can be imaginary, it can be real. That is what the boundary. And the system, surrounding and the boundary togetherly we can call it as universe. That is what a small idea about the system, surrounding and boundary. Everything is there in the PPT. I am not going into it because it's not that important. It's just an introduction part only. Okay, now type of boundaries. If I want to tell you what are the type of boundaries, they are classified as real boundaries, imaginary boundaries, diathermic boundary, adiabatic boundary. What is a real boundary? Real boundaries are those boundaries which are visible to my eyes. That is, example, if you are in the classroom, you are the system. If a classroom is a system, you are the particles in it, and the classroom is separated by other classroom by wall, right? So we can say the wall is a boundary, and that wall is visible to our eyes. So they are called as real boundary. And if I am talking about imaginary boundary, what is imaginary boundary? Example, if I am taking a vessel containing water, and if I am heating this water, what you can see, this water vapors will be moving to the surroundings, right? In which we can't predict which is the boundary, which is the exact boundary, because the water inside the vessel is actually our system, and the system is coming out from the vessel when I am heating. And here we can just imagine that boundary can be like this. That is what imaginary boundary. And what is diathermic boundary? Diathermic boundaries are those boundaries in which there is exchange of heat between system and surrounding. There is exchange of heat between system and surrounding. That is diathermic boundary. Yeah, how we can explain that one? If I am taking just take a bottle of water. If I take a bottle of hot water, after some times you can see the hotness of the water decreases and it becomes cool water, right? What is the reason? The boundary of the water, that is the bottle, that is actually diathermic. it will exchanges heat between system and surrounding. So that type of boundary we can call it as diathermic. Now adiabatic boundary. What is adiabatic boundary? Adiabatic boundary means there is no exchange of heat between system and surrounding. Example, I can say that if I am taking a thermal flask, if I am pouring hot water in a thermal flask, we can say that the hotness of the water will remain for a long period of time, which means the boundary or the thermal flask, the boundary, it is not allowing heat to exchange between system and surrounding. Those type of boundary we can say it is adiabatic boundary, in which Q will be equal to 0. Okay, so this is all about the idea about the boundaries or wall. Now we can move into the another basic of the thermodynamics, that is open system, closed system and isolated system. I am not going to tell or write anything about it. I will be just mentioning it, what is closed system, what is open system and what is isolated system. Open system means, yeah, just take a vessel of water which is kept opened. After some times what you can see, there will be exchange of both matter and energy, that is water will evaporate and it will escapes, which means there is escape of, yeah, Prathamesh Patel, you raised your hand, right? Any doubt, Prathamesh? Prathamesh, do you have any doubt, or you by mistake you raised your hand? Okay, I think we can move it. So in the case of open system, there is exchange of both energy and matter. It is kept open. And closed system means if I am keeping a water in a closed vessel, if I am keeping the water in a closed vessel, that is closed system. Here there is no exchange, of matter, but there is exchange of exchange of energy. That is what closed system. And for a closed system, what about the boundary? What should be the boundary of closed system? Is it real, imaginary, diathermic or adiabatic? Can anyone let me know in the chat box what is going to be the boundary of a closed system? I hope all of you are active. Can you just mention the boundary, students?
Diathermic.
Yes, very good, Sakshi. It is diathermic. The boundary will be diathermic because we need to exchange the energy. That is a boundary. And what about isolated system? For isolated system, there is no exchange. There is no exchange of energy as well as matter. And what about the boundary?
Adiabatic.
Yes, very good. It is adiabatic boundary. This is a small idea about the type of systems. Okay, hope it was clear to everyone. These are basic things only, just to have an idea about, that's enough. Shall I move? Give me some thumbs up, some reactions. Yes, thank you. Okay, now the next important point, that is intensive and extensive properties. Okay, intensive and extensive property, you can expect questions. The question will be asking like, among the following, which are extensive, which are intensive. Let's have a small idea about it. Intensive property which do not depend upon the quantity of matter, example temperature and pressure. And extensive property, they depend upon the quantity of matter, that is volume and mass. Example, I can just give a quick example. I am taking a container which is having some gas particle defined by the state parameter pressure P1, temperature T1, mass M1. Okay, this is in state 1. Okay, now what I am going to do is I am going to divide it into two equal parts. Now tell me what is the pressure of this system and what is the temperature and what is the mass. What is the pressure of the first piece, the second piece? What is the pressure of the first piece? Please respond. What is the pressure of the first piece? Students, pressure, is it P1 or is it P1 by 2?
P1.
P1, right, very good. And what about temperature? What about temperature?
T1.
T1. What about mass?
A1.
Mass is M1 or anything else?
M1.
Sure. I have cut into two pieces. Is a
M1 by
M1 by 2. Here the, yes, very good. Here mass is M1 by 2. Same as like here also P1, T1 and M1 by 2. Now here you can see on changing the mass, which are the properties that you can see that has changed and which are the properties that has not changed. Here you can see pressure and temperature remain same, right? Remains same. So those property in which there is no change in the value on changing the mass is called as intensity property. And here you can see mass has changed. Mass changed from M1 to M2, M1 to M1 by 2, which means it is depending upon the mass of substance, which means it is an extensive property. This is the easiest way you can understand what is intensity property and what is extensive property. Got it? Got it, everyone? One more point I want to add for the intensity property is intensity properties are additive in nature. Additive in nature. Sorry, not intensity property. Extensive properties are additive in nature. Intensity properties are non-additive, and extensive properties are additive in nature. Additive in nature. What is additive and non-additive means? If I am adding two extensive property, I will be getting the sum of it. But if I add two intensity property, I won't be getting the sum of it. That is additive and non-additive. So this is the summary of intensive and extensive property. Hope you got an idea about intensive and extensive. Is it? Students? Yes. Okay. Now I can give you the list of important intensive and extensive property. Have a note of it. I will be sharing it in the group, no worries. But you should be by hearting these values. No need to by heart. Few of the things you can understand. Which are the property that is not depending upon the amount of substance, they will be extensive. Like mass, volume, all the energy terms will be depending upon the mass of substance. All the energy terms depend upon the mass of substance. So whenever you got any energy, internal energy, enthalpy, entropy, Gibbs free energy or Helmholtz energy, all those will be extensive property. And apart from that, mass, volume, heat capacity, all these comes as the extensive property. This is the easiest way you can learn extensive or remember extensive property. Now thing is that intensity property, if you observe pressure and temperature already we have discussed. Then density means density will remain same whether it is in any quantity of matter. Example, density of 1 liter of water and density of 2 liter of water, both are 1 gram per ml. There is no change in that. So it is an intensive property. Okay. Then concentration, melting point, boiling point, surface tension, viscosity. These are the few intensive property I want everyone to take a note of it. Okay, you have to learn it, you have to remember it. This is a scoring part. It's a free question scoring part. Okay, shall I move? Yes. Okay, now we will be discussing about the state functions. What are state functions and what are path functions? Yes, Gayatri. What happened, Gayatri? You want to take a note of it? I will be sharing it in the group. You can write it. Or do you have any query in it?
Sir.
Yeah. What happened?
Sir.
I can't hear you. I can't hear you, Gayatri. It's breaking. Can you put in the chat box? you are asking for asking time for writing it on the writing it. Yeah, Gayatri, can you let me know what is in your mind? Okay, I am not getting any response from Gayatri, so I think I can move. Okay, yes. How some properties become extensive after dividing. After dividing, how some properties become extensive. I will be just telling it with an extensive after dividing it become not extensive, it become intensive. That is, if I am saying that if I am dividing two extensive property, if I am dividing two extensive property, that is mass by volume. Mass and volume, they are this is extensive, and volume is also extensive. If I am dividing these two, what is going to happen? I will be getting density, and the density is what? Intensive property. Like that, if I am dividing extensive property by volume or by mole or by a fixed quantity, what I am doing, I am fixing the quantity. Here mass I am dividing it by volume, which means I am fixing it for a particular volume. Because of that, the value that I am getting will be fixed for some particular mass. That is, density is fixed for particular amount of mass, that is particular gram and particular volume. So that is why it is intensive. Extensive, if I am dividing two extensive property, it will become intensive property, that is density, because I am fixing the amount of substance there when I am dividing. That's why it become intensive. If I fixes the amount of substance, yeah, of course, even if I change the mass, it is not going to change. Got it? Yes. Okay. Yes. Now we can move into the state function. What is a state function and how we can, yeah. Shall I move? Is it clear? Yes. What is a state function? State function and path function, these are the two important functions, and how we can define a state function and how we can define a path function. If the values depend only on the initial and final state of a system, they are state functions, and they are path independent. Even if it is go through any path, no matter, the value will be remains same. That is what state functions. Example, I can say, if I move from this point or this position to that position, or else example I can say, just A is moving to position B. A can move through different way. But which is the shortest path? From A to B, straight line is the shortest path, and this shortest path is not depending upon initial and final state of a system, right? It is what we can say, it is displacement, shortest path. Remaining we can say it is distance. If I am comparing displacement and distance, displacement is depending only on the initial and final state of a system. Yeah, very good. Displacement, final state of a system. In physics we are learning that one, which means that is independent upon the path. If any property which is independent on the path, that is what state function. But if I look distance will be different in different path. So those type of functions which are depend upon the path followed, it is called as path function. Okay. Now one more point is, we cannot calculate the absolute value of a state function. Absolute value of state function is not possible, because calculating all the energy, example, if I am taking internal energy is the sum total of all kind of energy. It is not possible to find out that sum total of all kind of energy. That is, we have to find out the energy in terms of microscopic viewpoint also. It is not possible. Only what we can do is we can find out the change in internal energy. So that is why absolute value of state function is not possible. We can only calculate the change in state function. And examples: internal energy, Gibbs free energy, enthalpy, entropy, all these are the state functions. All these are the state functions. Okay, and one more point I want to add is, for a cyclic process, change in state function for a cyclic process, it is equal to 0. Change in state function for a cyclic process, it will be 0. What is the reason? What is the reason? A cyclic process means what? Initial and final point are same. If initial and final point are same, delta state function will be 0. Okay, so this is a small idea about state function. Now what about path function? Path function, you no need to worry much, because we have only two path functions. There are only two path functions. Which are the two path functions? Heat and
Work.
yes, very good. Heat and work. These are the only two path functions available, and remaining all the functions are state functions. Got it? Yes. Now we can discuss about the different thermodynamic process. What is a thermodynamic process? What is a thermodynamic process? I will give an idea about it. It is a path followed to change the state of a system. If I want to change the state of a system, I can go through different paths. Which path I am choosing, that is what named by a particular thermodynamic process. Example I can give. Give that is, consider a system which is having some gas molecule, and it is defined by pressure P1, temperature T1, volume V1. What I am going to do is, this is in state 1. This is in state 1, and this state is defined by the state parameters P1, T1 and V1. And what I am going to do is, I am going to change the state of this particular system. I am going to change the state of this particular system. How I can change the state of the system? If I change any of these parameters, if I change any of these state parameters, I can change the state of a system. Got it? Okay, let's imagine that I am doing this. I am doing the change in state of a system by keeping the temperature constant, that is P2, T1 and V1. Here you can see I have changed the state of a system by keeping the temperature constant. So what is the path that this state has followed when it comes from state 1 to state 2? The path that it is followed is isothermal path, which means delta T is equal to 0. That is, if I move from state 1 to state 2 by keeping the temperature constant, that particular path we will be calling it as isothermal path, and the process we will be calling it as isothermal process. That is, for an isothermal process, delta T will be equal to 0. That is what thermodynamic process. It is a path followed to change the state of a system. If I want to change the state of a system, which path I am choosing, that is what a thermodynamic process. Got it? Understood, everyone? Guys, you understood the things? What is thermodynamic process? Yes, thank you. Now, if I am keeping the temperature constant, it is called as isothermal process. If I keep volume constant, delta V is equal to 0. If volume is constant, then it is isochoric process. And if I am keeping the pressure constant, it is isobaric. And if I am doing the process by keeping the initial and final state same, then they are cyclic process. And if I am doing the change in state of a system by keeping the heat exchange between system and surrounding same, they are adiabatic process. Okay, these are the type of thermodynamic process. This is a small idea about it. I will be going detail about it when I am after starting the first law of thermodynamics. Okay, so is it clear to everyone? Shall I move to the next? Students? Yes, these are very easy thing only. Now we can understand the graphical representation. Yes, Now we can understand the graphical representation of isochoric and isobaric. Isochoric, volume is constant. As volume is constant, we will be getting a pressure versus volume curve which is straight line to the pressure axis, And for isobaric, change in pressure is constant and pressure versus volume curve is parallel to the volume axis. For isochoric and isobaric, it's very easy. There is no problem in it, understanding the curve. Okay. Now how will be the curve for isothermal and adiabatic? Isothermal and adiabatic, if you observe, isothermal you can see delta T, temperature is constant, delta T is equal to 0. And for adiabatic Q is equal to 0. And the equation of state for an adiabatic process is PV raised to gamma is equal to K. Equation of state for an adiabatic process is PV raised to gamma is equal to K. Now how the graph? Look at the pressure versus volume curve for isothermal process and adiabatic process. Isothermal and adiabatic. Both look same, right? Both looks same. And if the question asks which among the following is adiabatic curve and which among the following is isothermal curve, how you can understand it? Anybody have an idea about it? How you can understand which curve is isothermal and which curve is adiabatic? If anybody know here, you can let me know. Sorry. Anybody? How we can understand which is isothermal curve and which is adiabatic curve? Both look same only. Yes, this is one of the questions that can come in the NEET exam. How we can understand this one is example I can say. Okay, I am drawing a line. This is pressure, this is volume. Okay, before going into it, let me tell you the exact idea. Okay, that is by comparing the slope. If you compare the slope of adiabatic and isothermal, you will be getting the slope of adiabatic curve is greater than slope of isothermal curve. That is, for adiabatic curve, what is the equation of state? For isothermal, you know that temperature is 0. When temperature is constant or 0, which is the gas law we can apply here? We can apply Boyle's law, right? What is Boyle's law? PV is equal to a constant. Now if I observe adiabatic, what is the equation of state for adiabatic? PV raised to gamma is equal to a constant. Now if you compare these two things, you will be getting the idea that slope of adiabatic curve is gamma times the slope of isothermal curve. Slope of adiabatic curve is gamma times slope of isothermal curve, which means slope of adiabatic curve will be greater than slope of isothermal curve. Note down this point. Okay, now I will be giving you the comparison of it. How we can understand which one is the slope of adiabatic and which one is the slope of isothermal? Okay, first one is curve line A, second one is B. This is pressure, this is volume. How we can understand that which is having highest slope or which is having lowest slope? What is the equation for slope? Slope, we know that dy by dx, which is equal to slope. Here y axis is p, so dp by dv is equal to the slope. dp by dv is equal to slope. So from this you understood that lower the change in volume, higher will be the slope. Lower the change in volume, higher will be the slope. Now we can understand that one. Okay, what I am going to do is I am going to check which is having lowest change in volume. For that, what I am doing is I am drawing a line and I am taking a same change in temperature, that is, this is P1, this is P2. For both the curve I am taking the same change in pressure, that is dP is same for both. dP is same for both the line. Now I am going to compare the change in volume of the curve A. Curve A I am comparing. Curve A, where it is having cut? It is having cut at this point, and the volume is, let's suppose the volume is V1 here, and here you can see the volume is V2. For pressure P1 the volume is V1, pressure P2 the volume is V2. Now this is a change in volume for delta V of A. Now I want to know the change in volume for which one? I want to know the change in volume for the curve B. Curve B, where the cuts we can see, you can see one cut at here, and the volume is here, this is the volume V1, and here this is the volume V2. Now if you observe the change in volume, delta V of B, which change is higher? Students, tell me which change is higher, delta V of A or delta V of B? Which change in volume is higher?
B.
Option B. B or A? Which change in volume is higher? Hello? Which change in volume is higher? A or B?
A.
Yeah, very good. A change in volume is higher. If the change in volume is higher, slope will be
Low.
lower. If the slope is lower, that is isothermal or adiabatic? Isothermal, exactly. Yeah. So from this we can understand that B is isothermal or adiabatic? B is adiabatic. Adiabatic, and A is isothermal, because lower the change in volume, small dV, higher slope. Isothermal, big dV and lower slope. Like that, like this you can find out which is isothermal and which is adiabatic. So the curve is isothermal and curve B is adiabatic. Is it clear to everyone? Students, are you clear with this one? This is one of the questions you can expect in NEET, because it's not a numerical but it's a conceptual question. What about others? Are you guys are focused on the class, or anybody have any doubt? Yes, thank you all of you for your response. Now we can move into the next. Yes. Yeah, here is the graphical representation. Now we will be moving into the first law of thermodynamics. Here the chapter actually starting. But before going to the first law of thermodynamics, you should be know about what are the terms that is involved in the first law of thermodynamics, that is internal energy, work and heat. First we are going to study about the two important path functions, that is heat and work. What are the things that is related to heat and work, that I am going to discuss right now. Yeah. First about heat and temperature. I hope everyone know what is the difference between heat and temperature. Both are not same. Heat is what? Heat is a transfer of thermal energy and its unit is joule. It's an energy. Heat is a form of transfer of energy. What about temperature? Temperature measures the degree of hotness and coldness present in a system, and its unit is Kelvin. This is the difference between temperature and heat. Okay. Now what is the main thing related to the heat capacity? That is heat capacity. What is heat capacity? These three are very important. Heat capacity. I will be explaining it. First of all, if I am asking you what is heat capacity, it is the heat required to raise the temperature of a substance by 1 degree Celsius. Example, I am taking this pen. I want to know what is the heat capacity of this pen. What I will be doing is, I will be increasing the temperature of this pen by 1 degree Celsius. Imagine that initially if the pen is having 25 degrees Celsius, I will be increasing the temperature by 26 degrees Celsius. How much heat I should supply for raising the temperature by 1 degree Celsius or from 25 to 26? That is what heat capacity of this pen. Heat capacity of this pen. Okay, and it is depend upon the mass. Heat capacity is completely depend upon the mass. If I break this pen into two equal parts, what is going to happen? Heat capacity of both the pieces will be different. Heat capacity of both the pieces will be different if I breaks the pen. Okay, that is what heat capacity. And what is the equation to calculate the heat capacity? Q is equal to C delta T, and here C is the heat capacity, which is equal to Q by delta T. Q by delta T. That is what heat capacity. What is specific heat capacity? Specific heat capacity means I am fixing some quantity. Specific. What is specific heat capacity? Imagine that this is a pen. I have found out the heat capacity of it. What I am going to do is I am going to take 1 gram of this pen. I am going to take a small 1 gram of this pen, and I will be increasing the temperature of this 1 gram of this pen by 1 degree Celsius. For that, how much heat I need to supply? For that, how much heat I need to supply? That is what specific heat capacity. That is what specific heat capacity. It is fixed for 1 gram of substance. Fixed for 1 gram of substance. How we can identify this 1 gram of substance? 1 gram of substance temperature difference heat. Q is equal to ms delta T, where S is the specific heat capacity. So S will be equal to Q by M delta T. M is the mass of the substance. It's quite logical only. That is heat capacity divided by total mass of the substance. What I will get? I will get the heat capacity of 1 gram of substance. Yes or no? Yes, I will get the heat capacity of 1 gram of substance. That is what specific heat capacity. Got it, everyone? Got it or not? Difference between heat capacity and specific heat capacity. Yes, thank you. Now what about molar heat capacity? Molar heat capacity is also same. I am fixing, here I am fixing something. What I am fixing? I am fixing it for 1 mole. Here I fixed 1 gram. Molar heat capacity I am going to fix for 1 mole. If I am taking 1 mole of this pen, how much heat I should supply to increase the temperature by 1 degree Celsius? That is what? Molar heat capacity. And what I have to do? Heat capacity divided by number of mole. That I will be getting molar heat capacity. These are very important ones: specific heat capacity, molar heat capacity, and heat capacity. Among these, we all know that heat capacity depends upon the amount of substance, so it is extensive. Specific heat capacity is not going to depend upon amount of substance. It is fixed for 1 gram of substance. If I ask specific heat capacity of this pen, and if I ask the specific heat capacity of the same pen after breaking it into 2 equal half, both the cases specific heat capacity will be same. So this is an intensive property. What about molar heat capacity? Molar heat capacity is intensive or extensive, students? Can you let me know? Is it intensive or extensive? Students, tell something. No matter whether it is. Yes, very good, Sangeeta. It is intensive because molar heat capacity also fixed for a particular amount. What is that particular amount? It is 1 mole. So this is also an intensive property. So this is a complete idea about the different heat capacities. Got it, everyone? Yes. Yes. Okay. Now this molar heat capacity I can measure. This molar heat capacity I can measure in 2 ways. Which are the 2 ways? Which are the 2 ways I can measure the molar heat capacity? By keeping the volume constant or by keeping the pressure constant. By keeping volume constant or by keeping pressure constant, I can measure the molar heat capacity. How I can measure it? At constant volume, the molar heat capacity will be equal to QV will be equal to NCV delta T. And at constant pressure, the molar heat capacity, that is Cp, and the equation comes Qp is equal to Ncp delta T. Qp is equal to Ncp delta T. Now the important point I want everyone to take a note of it. What is that? This Qv is nothing but it is the internal energy that you will be studying later. Qv, that is heat exchange between system and surrounding, heat exchange between system and surrounding at constant volume, that is nothing but the change in internal energy of a system. At the same time, the Qp is heat exchange between system and surrounding at constant pressure. It is nothing but delta H, that is change in internal energy. Very important, very important. Qv is delta U, Qp is delta H. Have you noted down everything, students? Yes. Okay. Now I am moving. One more thing I want to add is Mayer's relation. Mayer's relation is what? For 1 mole of an ideal gas, Cp minus Cv is equal to R. This was one of the previous year questions in NEET. This was Mayer's relation. Direct question came. For 1 mole, for n mole it is Cp minus Cv is equal to Nr. And one thing I want everyone to take a note of it is gamma is equal to Cp by Cv. This is called as Poisson's ratio. Poisson's ratio. And how you can find out the Cv value? How you can find out Cv value if you are given with gamma, that is Cv is equal to R by gamma minus 1. This you will be using in adiabatic process. I will be telling you that one. Note it down everyone. Another equation for Cv value if you are given with gamma, R by gamma minus 1. Yes. Note it down. Annotations you have to note it down because that won't be available in the PPT that I will be sharing. Okay. I think I can move. Am I? Can I? The heat is over. Yes. Now the heat capacity or the Cp and Cv value for different types of gases. Cp and Cv value for different types of gases. If for a monoatomic gas, Cv is equal to 3 by 2R. And we know that Cp minus Cv is equal to R. So Cp will be equal to Cv plus R. If you got Cv value, you can find out Cp value by adding one more R. So Cv is equal to 3 by 2R, Cp is equal to 5 by 2R, the Poisson's ratio, that is a ratio of it, 1.66. For monoatomic gas, this is the value. For diatomic gas or triatomic linear gas, diatomic gas or polyatomic linear gas, triatomic or it can be mentioned as polyatomic. What is the Cv value? It is 5 by 2R and for Cp it is 7 by 2R. For polyatomic non-linear gas, Cv value is 3R, Cp value is 4R, Poisson's ratio is 4 by 3. This you should remember. It is an important one. How the questions is coming is, they will be mentioning consider an ideal gas of helium atom. And in that question you might need to calculate or find Cv or Cp value. What is the Cv value for helium gas? What is the Cv value for a helium gas? Can anyone let me know? Cv value for a helium gas. What it is? By looking at the table you can tell me. Anybody can give the answer?
5 by 2.
Cv value for
5 by 2R.
5 by 2R. Are you sure 5 by 2R? Helium, what it is? It is a noble gas, right? Helium is a noble gas. And noble gas, are they existing in diatomic? No, right? Noble gas won't like to mingle with each other. They will be existing alone. They are monoatomic. As helium is a monoatomic, the Cv value is 3 by 2R. But if I am asking you what is the Cv value for a fluorine atom or oxygen atom, they are diatomic. They exist in O2, F2, N2 and all. What is the Cv value for them? For them it is 5 by 2R. Okay, this is how the questions can come. Got it everyone? Got it? Can I move? Yes. Okay, next we are moving into the work. Heat is over. Now the another path function, that is work. work, all of you know, it is a mode of transfer of energy. Mode of transfer of energy, it is a path function. And how we can categorize different types of works. Work can be two types. Which are the two types of work? Consider an ideal gas fitted with a movable piston. Fitted with a movable piston. And the pressure inside the ideal gas will be having some pressure. Let's imagine that it is pressure of the gas, and outside it will be P external. If pressure inside the gas is higher than the P external, if pressure inside the gas is higher than the P external, what will be the process happening there? If the pressure inside the gas is greater than P external, we know that there will be an expansion happening. We all know that there will be an expansion happening. Whenever there is an expansion, we can say the work is done by the system. Work is done by the system. That is, in the expansion, this piston will be moved out. This piston will be moved out, which means the gas inside the system is doing some work. Which means I can say the work is done by the system. Work is done by the system. And note down, whenever there is a work done by the system, at that time value of W will be negative. Value of W will be negative. Okay. Now at a particular point, what you can see is the piston will stop moving. The piston will stop moving at a particular point. At that point, I can say pressure of gas is equal to pressure of external pressure. In that case, there is no work. In that case, I can say that there is no work. Whenever there is no work, W will be 0. Got it? Okay. Now the another condition or another case, if pressure of the gas is lesser than external pressure, that is, pressure inside the gas, inside this container is lesser than the external pressure, what is going to happen? The piston will go inside. The piston will go inside, which means there is a compression. Which means you can see there will be a compression. Whenever there is a compression, work is done on the system. Work is done on the system. That is, this piston is doing something over on the system, right? Piston is doing something on the system. That is by work is done on the system. Whenever there is work is done on the system, W will be positive. W will be positive. And these signs are different in the physics, thermodynamics. No need to confuse, just opposite to it only. That is because of the way in which we are observing work and the physics is observing work. Both the way of observing is different. That's the way. Okay. Now that's all about expansion, compression and compression work. Okay. Now how we can calculate the work done? How we can calculate the work done? We have the general equation to calculate the work done. Calculation of work is V1 to V2 minus P external dV. This is the general equation to calculate the work done. This is the general equation to calculate the work done. Got it? Got it, all of you? Everyone? Expansion, compression and everything. Is it working? Is it working properly to you? Okay. Yes. Now this is the type of work, expansion, compression. Now this expansion, compression, I can do it in two ways. I can do this expansion, compression in two ways. What are the two ways in which I can do expansion and compression? That is by reversible work and irreversible work. What is the difference between reversible work and irreversible work? Reversible work means if I am doing a work very slowly, that is, if I am expanding a gas, this is the expansion. If I am expanding it very slowly, that is, first I will be decreasing the pressure, then volume will increases, then again decreasing the pressure, volume will increases, like that step by step, multi-step, step by step. If I am doing an expansion, that is reversible process. That is, it is a slow process, and we can say it is step by step process, a step by step process. And for reversible work, the calculation of work done equation is clearly matching with our general expression V1 V2, that is P external into dV. That is what reversible work. Now what is irreversible work? What is irreversible work? If I am doing irreversible work, if I am doing the expansion all of a sudden, suddenly I will be expanding it. Immediately I will be doing the expansion. It will be taking place in a very short period of time. That type of work is called as irreversible work, that it is a fast process. And this irreversible work takes place against a constant external pressure. It takes place against a constant external pressure. As it is taking place against a constant external pressure, this P external will be a constant, it will come out of it, and we will be getting the equation P external into delta V as the work done for irreversible process. Got it? How I am doing that expansion is, what I will be doing, first I will be decreasing the temperature all of a sudden. If I want to increase the volume, or if I want to do expansion, I will be decreasing the pressure all of a sudden, and in this constant pressure only the volume will be increasing. I will be decreasing the pressure all of a sudden, then at this constant pressure the volume will be increasing. After keeping the pressure constant only, the volume will suddenly increases. That is what irreversible process, and these two are the equations. Is it clear, everyone? Yes. Okay. Yes, now we can understand the graphical representation of reversible and irreversible process, and we can understand that which one doing more work, which one doing more work. This is the graphical representation of expansion work. That is, for reversible work you can see the work is starting from P1 V1, and it is taking place slowly. That's why it is following a curve like this. It's following a curve like this. And area under this curve, area under the PV curve will give the work done. This is the area under the PV curve. Area under PV curve gives the work done. Gives the work done. Got it? Yes. Now look at here. How the same work I will be doing irreversibly. Look at here. For irreversible, first of all there will be a pressure. Okay, let's suppose it is P1 and the volume is V1. It is initially at this point. What I will be doing is, I will be decreasing the pressure all of a sudden. And it will be reaching a pressure P. Imagine that it is reaching a pressure P, or it is P2. Now in this constant pressure only volume will be increasing. In this constant external pressure only volume will be increasing. This will be P2. Got it? That is, when I drops the pressure suddenly, the volume will expand very immediately, right? That is what happening in the case of irreversible process. So as the graph is following like this, area under this graph will be giving the work done. Now from this you understood that magnitude of work done in reversible or irreversible, which case more work is doing? Reversible or irreversible, where you can see more work is done? Irreversible more work is done? Are you sure? What is the area of reversible? This much area is there, right, in the case of reversible. And in the case of irreversible, what? Only this much area is only there for irreversible. Where you can see more area? Students, where you can see more area? Reversible you can see more area, which means work done in reversible expansion is greater than magnitude of work done in irreversible expansion. It's a very important one. Very important one. Okay, and one more thing I want to do is, whatever the final pressure, suppose in the question will be there, a system undergoes irreversible expansion P1 V1 to P2 V2, and if you are given with two pressure, how you will be understanding that in which pressure the volume has expanded? Among these, which one is the external pressure? Tell me. Among these, which one is the external pressure, P1 or P2? If you understood the graph properly, you can able to find out the answer. Which one is the external pressure, or in which pressure the expansion is taking place? P1 or Sorry?
P2.
Yes, very good. It is P2. If you got two pressure in the question, don't think that it is reversible work. It is irreversible work, and the external pressure will be the final pressure, P external. Final pressure will be the external pressure, in which this one we will be using it to calculate the work done. Got it, everyone? Got it all? Yes.
Yes, sir.
Yes. Okay. Now in the case of compression, I am not going to tell about compression. Compression is just opposite to this one only. In the case of compression, work done in irreversible compression is greater than work done in reversible compression. Note down these 2 points. Work done in irreversible compression is, sorry, Chesta, are you saying something? You are not audible properly to me. Yes. Shall I move? Yes. Okay. Shall I move? Yeah. Yes. Thank you. Yes. This is the 2 points you should note down. Yes. This is what the summary of what we learned. For expansion, it can be reversible and irreversible, and area under reversible expansion is greater than area under irreversible. So work done in reversible expansion is greater than work done in irreversible. And for compression, yeah, just opposite. Work done in irreversible compression is greater than work done in reversible compression. Okay. Now here is my question. Here is my question for you. Find out the net work in the cycle. Find out the net work. It is not Wi-Fi network. It is net work, total work. Find out, all of you. How you can calculate the work done if you are given with a PV curve? If you are given with a PV curve, how you can find out the work done? Area under the PV. Yes, very good. Area under the PV curve will be giving you the work done. So here you can see a triangle only. What is the area of a triangle? Half into BH. And what is B? Base. What is the change in volume here? 2 only, right? 2 V1 into base. Change in pressure. Height. What is the change in height? It is 5 P1. So what is the answer? 5 P1 V1. That is the work done. That is the magnitude of work done. Very simple. Don't lose any mark in this part. Find out the area. Whatever the geometry they have given, find out the area of that geometry and get the answer. That's only you should do it. Can I move, students? You got it? Yes. Here is another question for you. Identify in which reaction work is done by the gas and in which reaction work is done on the gas. Here is the question for you. I want everyone to try this question. It's a very simple question, and it's a particularly a NEET oriented question. Tell me about the first one. First one, is it going to be expansion work or compression work? We all know that. Which one is work is done by the system? Expansion is work is done by the system, and compression is work is done on the system. And for expansion, work done is negative. For compression, work done is positive. These points you should be remembering. First one, what is expansion or compression? Tell me, guys, expansion or compression? Need answer from everyone. Expansion or compression? 4 NH3 gas and 7 O2 gas molecule converted to 4 NO2 and 6 H2. Just check the number of moles. Here you can see 4 plus. In the case of first one, the 4 plus 7, which is equal to 11. 11 mole is converting into 6 plus 4. What it is? 10 mole. You can see the number of moles reduced, which means it is what? Number of moles reduced, or we can see what is happening here. Expansion or compression. Volume has decreased. If there is a decrease in volume, it is compression. Yes, very good. It is a compression. W will be positive. Compression. What about the second one? CO plus 2H2 gives CH3OH. Compression or expansion? Tell me. Compression. Yeah, it is compression. Why? Here the gas is converting into liquid. Gas is converting into liquid. So it is compression. So work done is positive. Now the third one, H2O solid is converting into H2O liquid. Compression or expansion? Tell me, guys. Compression. No work done. Are you sure? Solid is converting into liquid. Expansion or compression?
Expansion.
You will be thinking that it is expansion. You will be thinking that it is expansion because solid is converting into liquid. Yeah, but it is compression. Why it is compression? Tell me. Why it is compression? That's my question.
Gas is formed by volume is increasing.
Volume is increasing. From where to where? Which is having higher volume, solid water or liquid water? Solid water or liquid water? Yes.
Solid.
Yes, very good. That's the point here. Here you will be thinking that solid to liquid, so it will be expansion, but not. In the case of water, due to hydrogen bonding, volume of H2O in solid state is greater than volume of H2O in liquid state. That is, if you take a bottle of water, which is not completely filled, but it's almost filled, if you keep it in the fridge, if you keep it in the freezer, after some times you will be getting ice which is completely filled with the bottle, right? Ice will be completely filled in the bottle, which means volume is expanding because of hydrogen bonding. So as the volume is expanding, you can see, volume of solid is higher. So if I goes from solid to liquid, volume is decreasing, right? Which means it is compression. So work done is positive. Now what about the fourth one? H2O solid. Yes, solid is converting into gas. Of course, that will be expansion. Yes, solid to gas. Expansion. So work done is negative. So these are the points I want everyone to take a note about the work done. If it is clear, I can move to the next part. Are you all done with it, everyone? Yes. Okay. Now we will be moving into the first law of thermodynamics after discussing two important state functions. First one is internal energy. Internal energy is the sum total of all possible kind of energy present in a system. That is, if I am a system, if I have internal energy, which means whatever the energy present on me, that is rotational, kinetical, vibrational, potential, whatever the energy associated with me, that is what internal energy of a system. And it is an extensive property. Because if my mass has reduced, suppose I have 62 kg of weight, if my weight reduced to 50 kg, which means my energy also will be decreasing, right? So internal energy depend upon mass of substance, so it is an extensive property. Okay, then it is a state function, and for a state function cyclic process it is 0, and internal energy depend upon volume and temperature for real gas. For real gas, internal energy depend upon volume and temperature. For isothermal process, as temperature is constant, so delta U will be 0. Note down the point. Delta U equation I already have mentioned, NCV delta T, and for isothermal process means taking place against a constant external pressure. So delta U will be 0 according to the equation. Okay, internal energy. Here is a internal energy. Are you done? Shall I move? You can take a note from the PPT or PDF I am sharing. Okay, I am moving. Shall I move? Shall I move? Just note on the point delta U is equal to 0 at constant temperature, and for real gas it depends upon the volume and temperature. For ideal gas, how it is? For ideal gas, delta U is a function of temperature only. For ideal gas, delta U is a function of temperature only, that is NCV delta T. Yes, I am moving. Internal energy is over. Now the enthalpy, another important function. Enthalpy, it is a state function. For state function, final minus initial will be giving you the change in state function, and it is also an extensive property. And it depends upon both pressure and temperature for real gas. For ideal gas, enthalpy is a function of temperature only. And for 1 mole of ideal gas, the change in enthalpy dH is equal to NCP dt, which we already have discussed in the heat capacity, that is dH is equal to QP also. For an isothermal process, delta H is equal to 0. Note down the point. For an isothermal process, both delta H and delta U is 0. I can note down that here. For an isothermal process, delta H is equal to delta U is equal to delta T is equal to 0. Because the expression is same, NCP delta T and NCV delta T. Okay, and delta H can be negative as well as it can be positive. For negative it is exothermic, for positive means it is endothermic. I have a question for you. Which is more stable, exothermic reaction or endothermic reaction? Tell me, which is more stable, students? Exothermic or endothermic reaction? Exothermic. Yes, very good. Exothermic, because exothermic, it is an energy releasing process. If energy releases, energy of system decreases. If energy of system decreases, stability of system increases. That's the point. Okay, I hope all of you got an idea about enthalpy function. Now we are moving into the relation between delta H and delta U. Delta H have one more equation, that is delta H is equal to delta U plus delta PV. It is a sum of internal energy and product of pressure and volume. Product of pressure and volume. So delta H is equal to U plus PV, or H is equal to U plus PV, or delta H is equal to delta U plus delta PV. Now I am applying the condition. If the pressure is constant, delta H is equal to delta U plus P delta V. And if volume is constant, delta H is equal to delta U plus V delta P. These are the two equations you should note down. Okay. Now what is the last and final equation? For a gaseous phase reaction at constant temperature. For a gaseous phase reaction at constant temperature. For a gaseous phase reaction, the relation between delta H and delta U is equal to delta H is equal to delta U plus delta Ng RT. And what is this delta Ng? Delta Ng is equal to number of moles of gaseous product minus number of moles of gaseous reactant. That is what delta Ng value. And yeah, if I am writing a reaction, N1 plus N1A plus N2B gives N3C plus N4D. Okay, if it is a gaseous, if all are gaseous phase reaction, What is the delta Ng value for this one? What is the delta Ng value for this particular reaction? Can anyone let me know? What is the delta Ng value, students? Please let me know. Number of moles of gaseous product 0 according to this particular reaction.
N3 plus N4 minus N1.
Yes, exactly, very good. N3 plus N4 minus N1 plus N2. This is what delta Ng for this particular reaction. Okay, yes, this is all about the relation between delta H and delta U. Now shall I move to the next slide? You got an idea, everyone? Yes. Now the first law of thermodynamics. In the case of first law of thermodynamics, you need to note down only one point: delta U is equal to Q plus W. Delta U is equal to Q plus W. Now I will be applying this one in every thermodynamic process. Just note down delta U is equal to Q plus W. Hope all of you have noted down. Delta U is equal to Q plus W. Okay, now for isochoric process. For isochoric process, volume is constant. Volume is constant and work done is 0. Now if I apply, if the volume is constant, delta V is equal to 0, which means work done will be 0 for isochoric process, which means according to the first law of thermodynamics, delta U is equal to Q plus W. If work done is 0, delta U will be equal to Q for an isochoric process. Okay, now we can move into the next process. Delta U is equal to Q. I am moving to the next process. Shall I move, students? Yes. For isobaric process, look at the isobaric process. For isobaric process, pressure is constant. Okay. Now I am applying the first law of thermodynamics. Delta U is equal to Q plus W. Delta U is equal to Q plus W. As the pressure is constant, the Q will be P. Q will be QP. QP minus P external into delta V, as work done will be P external into V2 minus V1. So QP will be equal to P external delta V. And if I am taking out QP, which will be equal to delta U plus P delta V. QP is equal to delta U plus P delta V. Keep it here. Now coming to here, we have the equation of delta H. Delta H equation is equal to delta U plus delta PV, right? Delta H is equal to delta U plus delta PV. Okay, now at constant pressure, the equation will become delta H is equal to delta U plus P delta V. Now if you observe equation 1 and equation 2, what you can see? Both are same, right? Delta U plus P delta V. Now what I can do? I can equate these two, which means QP will be equal to delta H. QP is equal to delta H. I can write, right? Can I write it? Yes. Delta H, which is equal to delta U plus P delta V. Here I can verify QP is equal to delta H by this. Okay. Now there is one more thing, one more equation is there which we learned for delta H. What was that equation? Delta H is equal to NCP delta T. That also I can add over here. NCP delta T. So this is the complete equation related to the isobaric process. Note it down, everyone. QP is equal to delta H, which is equal to delta U plus P delta V, which is equal to NCP delta T. Yes, got it. Have you understood? Shall I move to the another process, another thermodynamic process? Yes. Now the next one is isothermal process. Isothermal process, there are some things you have to note down. As temperature is constant, delta T is equal to 0. As delta T is equal to 0, delta U will be equal to 0. If delta U is equal to 0 means Q plus W will be 0. According to the first law of thermodynamics, Q plus W will be equal to 0, which means Q will be equal to minus W. For an isothermal process, Q will be equal to minus W. Isothermal, Q is equal to minus W. Now I am moving. For isothermal, Q is equal to minus W. Okay, now we got to know that for isothermal Q is equal to minus W, and if W is equal to, and this can be either positive or negative, right? This work done can be either positive or it can be either negative. If it is negative, then it is expansion. If it is negative, it is expansion. And if there is an expansion or if there is work done negative, Q will be positive. According to the first law of thermodynamics, work done is negative means Q is positive. What does it mean if Q is positive? If Q is positive means heat will be heat absorbed by the system, which means for an isothermal expansion, heat will be absorbed by the system. Heat will be absorbed by the system for an isothermal process. Got it? Got it? Is it clear, everyone? Okay. What about compression? For compression, work done is positive. If work done is positive, then Q will be negative. What does it mean? Q is negative. Heat releases. If Q is negative means heat will be released by the system, which means for an isothermal compression, heat will be released by the system. Got it? The point is, for isothermal expansion, heat will be absorbed by the system. For isothermal compression, heat will be released by the system. These are the 2 points you have noted down. Got it? Now the important point is coming. This expansion, this guy, it can be either reversible expansion as well as irreversible expansion, right? It can be either reversible or it can be either irreversible. Yes or no? Yes. In which case there is more absorption of heat? That is my question. Anybody can anyone let me know if you know it? This is a particular NEET oriented concept. In which case there is more absorption of heat? Can anyone let me know? Reversible or irreversible? How you will be knowing it? In which? Yeah, reversible. You are saying reversible. Exactly, that is the correct one. How it can be? Yes, reversible. Yes, how it is reversible? How reversible work done lead to more absorption of heat? It's all about work done. It's all about the work done. In which case more work is done? Reversible expansion or irreversible expansion? Reversible or irreversible? Reversible expansion work done is greater than irreversible expansion. If the reversible work done is more, which means during the reversible expansion more heat will be needed to absorb. We need to absorb more heat, then only we can keep the temperature constant, because it is isothermal process. So because of that, I can say heat absorbed in reversible isothermal process is greater than heat absorbed in irreversible isothermal expansion. There is no numerical things here, only thing is that understanding. So it's a very important one. Okay. Now in the case of compression, can you tell me, in the case of compression also can be either reversible or irreversible compression. And in the case of compression, the compression is happening by releasing heat. Which case you can see there will be more release of heat. In which case there will be more release of heat? Reversible or irreversible? Yeah, who is going to give me the answer for this? Reversible or irreversible? Irreversible, very good. Irreversible. Why it is irreversible? Because work done in irreversible compression is greater than work done in reversible compression, which means which means more heat will be released. Where there is more work, there will be more release of heat. So I can write the statement, heat released in. Compression is taking place by release of heat, expansion is taking place by absorption of heat. So heat released in irreversible compression is greater than heat released in reversible compression. Yes, this is the complete idea about isothermal process. Hope all of you got a clear cut idea about it. Is it? Have you got the idea about it? Everyone, you should be clear with this. Yes. Okay. So this is complete idea about isothermal process. Yeah, can I move the slide? Are you done with it? Are you done? Yes. Okay. Yes. The same thing I have written over here, you can refer this slide. Yes. Now for the work done calculation. Now for isothermal process, work done. Just wait, one more point is there, after that you can leave. Work done calculation. For reversible isothermal work, calculation work done in reversible isothermal process, that is work done is equal to minus 2.203 nRT log V2 by V1, minus 2.3 nRT log V2 by V1. Note down and remember this equation. And according to the Boyle's law, P1 V1 is equal to P2 V2. So in terms of pressure, I can also write the equation, that is minus 2.303 nRT log P1 by P2, log P1 by P2. And for irreversible there is nothing to think, that because it is taking place against a constant external pressure, there is no need of integrating anything. So work done will be minus P external into V2 minus V1. For irreversible, the equation is same. Work done in irreversible process is same, is equal to minus P external into V2 minus V1. This is the point. This is the complete idea. Got it, everyone? Have you noted down? Have you noted down, everyone? Yes. This equation is important because one of the numerical questions that you can expect from this part is based on this equation. Okay, this is the complete idea about isothermal process. Now the next process or a question I want to give a question. Yes. Sorry.
We using log 10 compulsory.
I didn't get you.
Previous slide, sir, work done.
Yeah.
Formula we using log 10.
Yeah, log 10. If you are using log 10, then it should be multiplied with a minus 2.303. If it is natural log, W will be equal to minus nRT ln. Here this is ln to the power E only, V2 by V1. If it is using the natural log ln, it will be minus nRT. If it is log to the base 10, it will be minus 2.303, because the conversion from log to ln is 2.303, that difference. Got it? Got it you? Yes. Now here is a question for you. 6 mole of an ideal gas expands isothermally from 1 liter to 10 liter at 300 Kelvin. Give me the answer. I want answer from everyone. After this question we can wind up the class. I know this chapter is not over. I will be continuing this chapter in the next class. Okay. Give me the answer, students. 6 mole of an ideal gas expands isothermally from 1 liter to 10 liter, which means the volume V1 is equal to 1, volume V2 is equal to 10 liter, and temperature is 300 Kelvin. And here the question is maximum work done. Maximum work done. Here nothing is mentioned about whether it is reversible or irreversible. Nothing is mentioned whether it is reversible or irreversible. How you can find out whether it is reversible work done or irreversible work done? How you can find it out? Tell me, students. Only mentioned maximum work done, and it is expansion. Who is going to give me the answer? Anybody have any idea? Yes, Sangeeta, you are saying something?
Reversible.
Reversible, very good. Why it is reversible?
reversible.
Yes, why it is reversible? Because here,
Maximum work done in
yes, exactly, that is, we know that work done in reversible expansion is greater than work done in irreversible expansion, which means this process is reversible process. For reversible process, what is the work done equation? Minus 2.303 nRT log V2 by V1. Now substitute the values, you will be getting the answer, and you can take the value of R as 2 in terms of calorie. So minus 2.303 n. What is the value of n? N is equal to 6. R is 2. Temperature is 300. And log V2 by V1, 10 by 1, it is log 10. What's the value of log 10? It is 1. So, yeah. So now you can solve the question. You can just multiply it and you will be getting the answer. Okay. Yes. So this is
34.46.
34 point. Yes, is it? Are you sure? Minus 89 something it is coming, I guess. Okay, no problem. You can just calculate later and you can find it out. I think something 89 something it is coming. Okay, we can check it later. No worries. So this is the end of the today's class, students. No worries. I know that I have taken a little bit time here because lot of understanding is required for this chapter. We will be continuing this chapter in the next class, and I will be giving a clear-cut idea about complete equation and concept about this chapter. Okay. So yeah, this is a part. Before that, I want everyone to go through this chapter at least once, because without a small idea about this chapter, it's very difficult to understand the crash course. I know it is difficult, that's why I have given a little bit detail of it. Okay, so that's all about the today's class. Yes, thank you for joining. We'll see you in the next class. Yes.